All right, welcome America, welcome India, and welcome Selena Gomez, live studio recording of pre-calculus. We are going to graph a cosecant function. I'm going to try and be efficient so this video isn't super long. I've already kind of started the problem for you. So we are graphing f of x equals the cosecant of 3 theta plus 4 pi and then minus 3. So the way we want to think about this is we want to first think about the reciprocal function to cosecant is sine. We want to plot the points of the sine function. This were sine functions. I went ahead and rewrote it first as a sine function and started filling in some of the information here. The amplitude of this sine function is 1. The period is 2 pi over b. b is 3, so the period is 2 pi over 3. Chunk that into nice equal 4 pieces. So I'm going to divide by 4 or multiply by 1/4. So the unit is 1/6. I went ahead and put that on the graph. And clearly the vertical shift is going to be down 3. So the midline is at minus 3. And I should probably draw it in there right now, because that is one thing I always seem to forget. There we go. That is going to help me graph. Now, the phase shift is when we take the parentheses and we set it equal to 0. So let's go ahead and do that, maybe in a different color. 3 theta. When I set this equal to 0 and I subtract the 4 pi, it's going to go to the other side. So I'm just going to write it as negative 4 pi, solving for theta. So my theta is negative 4 pi over 3. Well, the period is 2 pi over 3. So that's 2 full periods to the left. We'll go ahead and do that phase shift, but I'll show you something afterwards. So the phase shift is negative 4 pi over 3. So that's like our H and that's like our K. So we're going to be shifting left 4 pi over 3 and down 3. So let's start there. So we're counting. We don't really even, if you're shifting left or right 1 period or 2 full periods, the graph repeats. So you don't really have to even do the shift if it's the shift is exactly the period. So I think we'll just, knowing that the graph is going to repeat, I'm not going to go to the left 4 pi over 3. It's going to be the exact same place as if I were here and went down 3. So let's start there. Now this point is going to be on our graph because we're graphing, starting with the graph of the sine function, and 0, 0 is on our function. If we were graphing cosine, then we'd have to use the amplitude to find our starting point. Okay, so now we've got our starting point. So I'm going to go ahead and circle it. And if I were graphing the sine function, I would be, because we've got a positive sign, we don't have a reflection over the x-axis, we're going to start high, right? So 0, high, 0, low. I'm going up 1 because the amplitude is 1. Nice. Okay, now, if we were graphing the sine function, we would go ahead and nicely draw in our curve. However, now we're going to shift to think about graphing, not the sine function, the cosecant. And as we were talking about earlier, anytime we had a 0, okay, the reciprocal of that is undefined. So all of these zeros, that's a 0, that's a 0, that along our midline are going to end up being, they're going to change from zeros to asymptotes. So I'm going to go ahead and use a highlighter and draw those in light blue. So I'm going to change all my zeros to asymptotes. So we're cutting a period in half. 1 full period, now we've got an asymptote right in the middle there. That's going to be important in a minute when we're doing the domain. Good enough. Wait a second. Did I miss a point? I did. miss a point. Good. 0. All right, low, 0, high, 0, low. There we go. Asymptote, asymptote, asymptote. Nice. Now, so I don't get confused. Okay, I just changed all those zeros to asymptotes. We're almost done. Because now all we have left are the highs and lows, and we're going to draw our graph then. And we want the graph to be approaching the asymptotes. So the high is going to approach the asymptotes this direction, and here's the low. Good enough. Now, the domain is all the x values except the asymptotes. So we have to identify where are the asymptotes. The first asymptote is right along our y-axis. So the distance to the first asymptote is half the period. So my domain, I don't have to state the first one because we're at 0. I can just say it's half the period times k. In this case, the period is 2 pi over 3, so half the period is pi over 3. So we can just say x cannot be equal to pi over 3k. Because every pi over 3 we have an asymptote. And then we add another pi over 3, and we have an asymptote. And then we have another pi over 3, and we have an asymptote, another pi, and so on. And the range is negative infinity up to and including -4. And the way we include that is with the hard bracket in union with, looks like, is it -2 to infinity? Including the -2. And that's it. Peace out.